Good evening, everybody. Welcome to our next lecture in the SCI-Arc lecture series. Herwig Baumgartner and Scott Uriu. My name's Tom Wiscombe, if you don't know me, and I want to just give a couple of facts about these two guys in case you don't know them, and then I want to show a few slides, and we'll go from there. So first of all, Herwig went to school in the Angewandte in Vienna. So he's Austrian, and he spent a long time working for Frank Gehry here at a very high level in Los Angeles on projects like the Disney Concert Hall and Novartis, which is an all-glass building in Switzerland, and started with Scott their office, I think, around 10 years ago at this point. It sounds right. Scott Uriu teaches at USC. He teaches at SCI-Arc. He's from California, and was working, at the same time as Herwig at Frank Gehry's office for Gehry Partners, and worked on the Experience Music Project and other projects. I don't know if you worked with Herwig actually, but I think you did. So anyway, so their office is B+U. It's about 10 years old, and the way I see it, they have a couple of eras even in their own work. And I just want to make a couple of comments about their more recent work. But before I do that, I want to talk about this slide on the left. Because Herwig and I share Vienna, of course, every time I mention his name, Baumgartner, I always think of tree gardener, which is what it means. And I thought somehow tree gardener has something to do with his work. Especially his work recently in trying to combine issues of biology and architecture and technology. But then I found this image, and I thought it was even more relevant for this particular lecture because it's about the uncanny, I'm brought to believe. And so I thought how interesting that there's a house in the back. Das Unheimliche means, of course, versus heimliche, which is house-like or homely. Homely means something different in English, but something that's homely in German means something that's familiar. And so das Unheimliche means something that's unhomely or unfamiliar. So that's just another angle on this image that I liked. Of course, when you type in Scott Uriu into Google, nothing specific comes up. So otherwise I would show a slide on that. Okay, so the work that Herwig and Scott have been working on the last couple of years, from at least my vantage point, has been a lot about the issue of apertures and architecture, and I've been very interested in how specific that interest is, and also in how it's really a defining quality of architecture. And if you look back through, I can hardly see the slide from here, but if you look back through history, of course, way further back than these slides go, but you have this issue of how to perforate or how to connect, or how to perforate surfaces or how to connect the outside world with the inside world. And sometimes that has to do with letting things that are outside inside through holes, or it has to do with the subject inside of a building looking outside. So in Le Corbusier, you have, of course, the ribbon window, which is about framing a view. You have in Notre Dame this telling of a story through a window, so this kind of passage of light, but also the telling of a story. And you have Mies van der Rohe not making an aperture per se, but in fact the whole building in Friedrichstrasse becomes like a window into another dimension. It's a kind of mirror window or a hole into another parallel universe. And I think one which may relate most to Scott and Herwig's work is the Louis Sullivan, the bank building at the top, where aperture is no longer a hole in something else or a lack in something, but it's an additional piece that has its own contours and edges and sort of objecthood. So, and I want to say, I think it's, I was thinking about their work, and I couldn't decide if it was more, if their recent projects are more like eyes in the sense of something looking out, or if they were more like mouths, which is more like bringing something in. And I'm looking forward to hearing their angle on that. And in particular, why one should even be looking at mouths and eyes rather than faces and bodies in architecture. And I think it probably has something to do with their interest in post-humanism. And then finally, I want to mention black holes because I haven't seen it yet, but for anybody who's seen Interstellar, which is the most recent Nolan movie, it's pretty interesting that our idea of a black hole is in a way, turns out to be a paraphrase of what a black hole really is. That we always imagine a black hole as being a kind of a water leaving the drain of the sink or a kind of a tube into some other dimension. But in fact, as we know, as Hawking knew when he discovered black holes, but also as we have come to know even further, the black hole is not a lack or a lack of something or an emptiness of something, but it's in fact a three-dimensional object. And so that rendering in the middle is what happens when you use contemporary science and contemporary rendering fidelity to actually figure out what a black hole really looks like when you can't get near to one. So that's what happens when you turn a hole into an object. And then finally, on the far right, which I can barely see, the pupil of the eye is like a black hole. You're seeing out of it, but when you look deeply into it, you also see into infinity. So I hope that that Herwig and Scott somehow respond to some of these questions. I think they will. I'm pretty sure they will. So anyway, join me in welcoming them to the stage, and good luck. Thanks.
Thank you. That was a very nice introduction. And I hope we can answer some of these questions. It's funny, we even have some of the same slides. Okay, so our lecture title, The Familiar and the Uncanny. For us, the familiar and its relationship to the uncanny is a lens through which we can look at our work. How familiar is it, or how uncanny is it? The uncanny for us opens the door to the unknown, yet it has one foot in reality and one in fiction. It is this duality of multiple realities that is of interest to us, and how to achieve this in architecture. We find the work intriguing if it doesn't completely reveal itself at first, and remains not just mysterious, but often strangely familiar. There are a few books and essays written about the subject, starting with Freud's essay about the uncanny or das Unheimliche from 1919, where he was perhaps the first to foreground the distinctive nature of uncanny as a feeling of something not simply weird or mysterious, but more specifically as something strangely familiar. Freud discusses the example of something that is concealed and kept from sight as an essential factor in producing uncanniness. Anthony Vidler's book, The Architectural Uncanny from 1994, in which he interprets contemporary buildings and the interest in the uncanny as a metaphor for fundamentally unhomey modern conditions. And finally, Graham Harmon's book, Weird Realism, Lovecraft and Philosophy from 2012, in which he extracts the basic philosophical concepts underlying the work of H.P. Lovecraft, an American science fiction writer yielding a weird realism, which has become increasingly popular in philosophy and architecture alike. Our understanding of weird realism involves processing of the environment relying on representational modes that engage both various forms of abstraction as well as conventional forms of resemblance, although fully aligning with neither. Rather, we are interested in producing a strange fusion of the two. So to set the stage, we want to show a few different approaches to the subject, which have, to varying degrees, been influential to our work. For our friend, artist Michael Rees, the purpose of the work is uncanny, to give the feeling of something that is known and to point to what which is not known or to that which is strange. It is this sense of the uncanny that suggests new possibilities. In his essay, Art as Technique, Russian writer Viktor Skolovsky describes the unfamiliar as following. The purpose of art is to impart the sensation of things as they are perceived and not as they are known. The technique of art is to make objects unfamiliar, to make forms difficult, to increase the difficulty and length of perception, because the process of perception is an aesthetic end in itself and must be prolonged. It often is surprising how little it takes to estrange something by either adding features that don't belong or by leaving them away, like Rees eliminating the torso and using only limbs to invent a new creature. It's funny and mysterious at the same time. When Cremaster 4 by Matthew Barney came out, we were both still in architecture school, and the film had a huge impact on both of us. It is set on the Isle of Man, which is in real life the backdrop to one of the most prestigious motorcycle races in the world. Barney constructs two realities in this film. One that deals with the motorcycle sport, its obsession with logos and colors and speed, while at the same time there's another reality going on just underneath the surface that slowly starts manipulating and invading the events above ground. The uncanny happens when the subterranean world starts oozing into the reality of the race, which in the end has fatal consequences. At the other end of the spectrum, and a lot closer to Freud's Strangely Familiar, is the movie Gattaca and Gregory Crewdson work Beneath the Roses. Gattaca presents a future society in which children are conceived through genetic manipulation to ensure they possess the best hereditary traits of their parents. The film centers on Vincent, played by Hawke, who has conceived naturally and struggles to overcome genetic discrimination to realize his dream of traveling into space. This is probably one of our favorite science fiction movies. It looks so deeply embedded in the familiar and the real, with the fiction just hovering slightly below the surface. Crewdson's work, on the other hand, is situated in a genre within photography that deals with constructed realities. It is in its techniques closer to a movie production than to still photography, and uses elaborately designed scenes and lighting, much like a movie set or a matte painting, to create the illusion of an environment that is non-existent in real life. Influenced by people like David Lynch and Cindy Sherman, Crewdson constructs these hyper-real scenes that have embedded in them multiple narratives that produce this strangely familiar reality. And the closer you look, the more you zoom in, the more uncanny they become. For example, in the image on the right, Crewdson sets up a scene in what seems to be a motel room with a woman and a baby. The way how the scene is lit with no reflection on the glass and all the curtains pulled back collapses inside and outside into a single space. The contrast between the naked baby and the snow, as well as the posture of the woman and the baby on the bed, and the enhanced coloration just around the character, produces an uncanniness and intellectual uncertainty of what might have happened. In architecture, these uncanny moments are much harder to find, but if they do happen, they are even more powerful, like the opposing of two completely unrelated objects into a new reality in Hans Hollein's photomontage of the aircraft carrier in the landscape. Or architecture that is being augmented with sound and projection into a totally immersive environment in the Philips Pavilion, which was a collaboration between Edgar Varese, Yanis Xenakis, and Corbusier. Varese's composition, the projected images from diverse resources, including human figures as well as Godzilla, and the skewed and undulating form of the building all conspire into the production of a defamiliarization effect. Something Sylvia Levin also touches upon in Kissing Architecture with the example of Pipilotte de Rist's video installation in a MoMA. There's also architecture's obsession with endlessness, which means the breaking down of barriers between the architectural object and its users. Like in these two projects by Friedrich Kiesler, the one on the left, obviously the Endless House, and the one on the right, the less known Universal Theater. The dissolving of barriers between inside and outside and how to transition from a monolithic object to a fragmented space has been of great interest for our work, and is still something we're trying to resolve. One of the buildings that probably does this best, the dissolving of barriers and creating a sense of endlessness, at least for us, is Sharon's Berlin Philharmonic building. It is a building that unfolds slowly as you move through it and is full of surprises. It's an incredibly powerful project. Even after having been there many times, it's still one of the most uncanny spaces we know. It's a space full of mystery that doesn't just produce a spatial effect, but it also makes the visitor part of the act, and it changed how we listen and perform to music in this kind of formal setting. So for us, the teasing out of the uncanny can affect every aspect of architectural practice, from methods of representation to manipulation of architectural components like apertures, surface, and mass, to materials and methods of construction. For this lecture, the uncanny is defined in relationship to manipulation of a specific set of architectural components that we have been working with over the past few years, which is apertures, edges, and multiples.
So apertures have been an ongoing topic in our work. We've been interested in challenging the notion of an architectural opening as a static object by redefining the DNA of a window, both in terms of its appearance, materiality, and as well as its nature as an object in continuous flux, responding to its environment through movement or sound. On a very basic level, the window makes the facade. They determine what a house looks like and feels like, while from the inside, they frame the view and bring in air and light into the building. Based on the exterior appearance, they differentiate between themselves into categories, such as the punched hole window, the glass curtain wall, and apertures, which are objects protruding from the facade, etc. However, beyond that, windows can also express an architectural idea. They have symbolic meaning that has nothing to do with the performance as a window. For example, Jeff Kipnis speaks about the windows of the Jewish Museum by Daniel Libeskind as being about a tragedy that occurred in human history and how this was translated into an architectural term. Quote, "These windows are not about light, they're not about air, they're not about views as we would normally associate them. They make the thing look, let's say, tortured, fragmented, broken," end quote. In Corbusier's manifesto, The 5 Points of Architecture, which is most evident in the Ville Savoie, he claims the ribbon window as one of the key features of modern architecture. The facade can be cut along its entire length to allow all rooms to be lit equally. The ribbon window also does something else. It frames the horizon and denies you from seeing the sky and the ground as you otherwise would through a floor-to-ceiling window, turning life into a film strip. We were looking into building upon these two ideas, but simultaneously transforming them into a totally different approach that deals with the aperture as a foreign object inserted into the surface, causing the surface to rupture and deform. Our interest in apertures developed while working on a housing tower in Lima, Peru. For us, the typology of the housing tower was less defined by the aggregation of organized units, but actually more defined by fenestration, the window.
So what is the quote-unquote DNA of an aperture? Our approach can be basically, or we try to group our approach into 3 topics or points: the aperture frame, apertures as autonomous objects, and apertures as responsive systems. And so we will elaborate these topics mostly on the hand of 2 projects. One you very well know is the installation we did for the gallery last spring, and the other is the housing tower we did for Lima, Peru a few years ago. So the aperture frame. Apertures are features of the face, just as eyes, mouth, and nose are features. Apertures are features of the facade, of course, just as the eyes, mouth, and nose are features of the face. We are accustomed to seeing certain shapes and forms of window frames that we are familiar with and which communicate to us a certain embedded logic, performative, historic, symbolic, etc. So changing the shape of the window frame, even if ever so slightly, is easily conceived as uncanny or strange. There are 2 art pieces that have had great influences on our work on this topic. One is Bruce Naumann's Making Faces from 1968, and the other one is Tim Hawkinson's E-Motor from 2002. Naumann's work deals with the deformation of facial features, which in themselves can be familiar depending on the degree of distortion, while Hawkinson deals with the dispositioning of parts of facial features through a mechanical apparatus that reconfigures the mouth, eyes, and nose. Although the work of Hawkinson and Naumann are related to one another, the results are dramatically different and show a clear shift from the familiar deforming Naumann to the uncanny dispositioning Hawkinson. Based on that logic, we started developing a window frame that is in flux and can change its shape over time rather than having a static frame with a specific form. So for the housing tower, the window frame was designed with linear extensions along the window frame that created a soft, blurred building edge on the exterior that is constantly in flux. While for the SCI-Arc Gallery, the focus was on deformation of the window frame that was augmented with a heat sensor and sound into a responsive architectural environment. So we're interested in this threshold between familiar and the uncanny that can be produced simply by changing the frame, like in this aperture study for the ship terminal competition we did for Keelung. So I'm gonna just let this play for a few seconds. This is a housing tower for Lima, Peru. I'm gonna explain a little bit more in a second. So for us, the housing tower, for the housing tower, we developed two families of similar apertures, an inverted and an extroverted type. The extroverted type is an occupiable aperture and protrudes beyond the building envelope, forming balconies and semi-outdoor spaces. The inverted type pushes into the interior and cuts into floor slabs, producing vantage points that are visible from multiple floors. These apertures, as individual autonomous objects, set the aesthetic for the project as a whole, as well as its interaction with the surrounding neighborhood and context. The linear extensions are kept constantly in motion through environmental forces like sun and wind. They perform as shading devices and produce a small amount of energy through solar thin film coating and motion. We imagined that these apertures would be made out of advanced silicon composites that mix material properties on a molecular level, similar to technology used in 3D printing, although they are able to move without any mechanical parts. That was at least the goal. So the building section was really important because it shows the transition from inside to outside and gradually erodes the edge of the building. Apertures can cut and push into floor slabs. They can be deployed independently of floor plates and across multiple building surfaces. The aperture in this case is a spatial component that cuts into the floor plates, then transitions into a balcony and finally dissolves into these very fine-grained extensions of the frame. It produces a building silhouette that is constantly in motion and blurs the boundary between building mass and city. The project is at the edge of a large park and about a mile away from the ocean. It was important to emphasize these two views and incorporate these large terraces into the aperture as a transitional indoor-outdoor space. This is as far as we have ever gotten to build a prototype of these apertures. This is a 1:100 model, which is about 4 feet tall, and was exhibited at last year's Archilab show in Orléans in France. The model was bought by FRAC and is now part of the permanent collection. But we are still exploring ways on how to build an actually working one-to-one prototype for one of these apertures.
So apertures as autonomous objects. We reconsider apertures as autonomous objects, three-dimensional objects that are independent from the building enclosure in terms of their morphology and materiality. They can operate as a transitional object between inside and outside, adding specific features to the overall massing. For example, the roofscape of the Unité de Habitation by Le Corbusier uses large cone-shaped apertures, both as skylights and as sculptural objects on the roof. Or the Scottish Parliament by Enrique Morales, which seems like a thesis on apertures as autonomous objects. Playfully deploys apertures with different articulations, materiality, to give the project its unique character. Or the work of Lee Bontekoe and her obsession with the openings and things inside of things. There's a certain liberty implied by disengaging the aperture from its host, the building. Apertures begin to act as spatial devices rather than just a cut in the surface or a change in material. Apertures are directional and can be aimed at certain vantage points. Apertures as objects can be designed independently from the logic of the surface and inserted back into the building. This type of aperture produces an architecture that appears incongruous. For us, the installation at the SCI-Arc Gallery was a perfect opportunity to test all of this out. We deployed 30+ apertures that were inserted into the smooth surface, causing deformation and disruption. Although one would expect that adding these disruptive features would structurally weaken the overall design, it did exactly the opposite. The double curve deformation and local thickening of materials through the apertures became a structural strategy for how to stiffen particularly weak areas. Color was applied very delicately, and the inside of the apertures were painted lime green, reflecting the color indirectly into the surrounding space, thus emphasizing the interactive sound component embedded within each aperture. The installation was designed using a technique of aggregation as a family of discrete and self-similar objects, or flutes, into a larger whole. On the interior, the surface edges were, the trimmed surface edges produced an ordering system of structural ridges that highlight the seams between the objects, while simultaneously connect the different apertures and converging into a single interior space with multiple vantage points. The outside does the opposite. It's an extroverted, multi-directional object with a strong silhouette playing off against the flat gallery walls. The interior, or the two different types of spaces, were emphasized through a high glossy white finish on the outside, while the interior was painted flat white.
Your thing. There we go.
All right, responsive systems. The last point has to do with augmenting apertures through movement or sound. As mentioned before, our example of the housing tower in Lima, Peru, apertures respond to environmental forces like the sun and the wind through a swaying motion and produce small amounts of energy through solar thin film coatings and provide shading. The architectural effect is both spatial and performative. In the SCI-Arc Gallery piece, the openings respond to their environment through heat sensors and sound. The apertures become a vehicle for interaction, encouraging the observer to physically engage with the work through feedback and adaptation between biorhythms of the human body and its environments. The sound component refers to John Cage's observation of two bodily sounds one might hear in an anechoic chamber that resulted in his famous composition 433. The high sound is one's nervous system in operation, and the low sound is the circulation of one's blood. While inside the pavilion or engaging with this aperture, sensors pick up the biorhythms of the visitor, which are then processed through an algorithm, creating a live sound feedback. The sound simulation was done in collaboration with Vienna sound artist Hannes Kecker. The effect was an inner body sound experience where one was immersed in a polyphonic mixture of low and high frequencies, simulating the sounds of one's bloodstream and nervous system. As architects, we have been fascinated in finding ways to manifest interaction with the physical object or spatial relationship into a more enveloping experience.
So to conclude this topic of apertures, we want to show a competition entry for a caricature museum in Krems, Austria. There was a perfect venue to explore the idea of the deformed aperture frame further, since caricature by definition deals with exaggeration and deformation of facial features, to make a point. The project is an expansion of an existing caricature museum by Gustav Beichel and the Kunsthalle Krems, two buildings that were supposed to be linked together with a new museum. So urbanistically, the project connects not only multiple buildings into one new museum, its mega apertures also set up visual references to important landmarks in the city. In terms of organization, the ground floor houses all three temporary exhibition spaces, a restaurant and the main lobby and ticketing, and the galleries are mostly on the upper floors and connect both the Kunsthalle and the existing caricature museum. The building is kept in black and white and deals with exaggeration and deformation of apertures as a reference to the content of the museum. The second topic we want to talk about is edges, and the articulation of edges and how they can estrange and otherwise familiar objects through blurring or shredding the pristine silhouette. This has been a topic in many of our projects. The dissolving of surfaces and edges, or the transition from inside to outside through a fragmented spatial element, was yielded to two different approaches in our work. One where the architectural object is expressed as an ambient figure, and the other where the edges appear to be torn. In both cases, there's a strange fusion between the familiar architectural object and the abstraction of its edges to produce a new, uncanny one. So for example, on the left, Michelangelo's sculpture, The Four Slaves, the figure seems to be trapped in a rock, and it is unclear if it was just never finished or if it's purposefully offering an uncanny reading of the object. The edges of the figure or their transition from form to non-form are blurred. The other approach is one of decay, where edges are dealt with by shredding or dissolving them, like the stress by Alexander McQueen on the right. There's an idea of dynamism and motion that's implied. So 2 architectural projects that engage this topic in very different ways are Jean Nouvel's Akbar Tower in Barcelona, which blurs the edges and softens the silhouettes through glass lamellas and color. And John Haydock's House of the Suicide, on the other hand, deals with edges in a much more aggressive way, where the walls of the house resolve themselves into this hyper-articulated, spiky roof. Both projects are concerned with similar issues of silhouette, how the building edges get resolved against the surrounding context. And both approaches yield to an architectural object that can be conceived as uncanny.
Edges and how they can be pulled out of a single volume to form a spiky, multi-directional silhouette was one of the main features of this public art project for Sunset Junction in Silver Lake, where we were shortlisted for. The point of gravity is moved up from the ground, and we end up with this star-shaped object that has loose ends on all sides. Edges were also a focus for our pedestrian bridge designed in front of the Hermitage Museum in Amsterdam. It's a 100-meter long bridge with a small store, a cafe, and a bike repair shop incorporated into it. The intention here was to create a bridge that was not dominated by the typical engineering aesthetic that embodies most large span bridge designs. Instead, we were interested in a less organized type of structure, one where the structural logic wasn't immediately apparent. We tested the bundling and tangling as a strategy to produce a structural stiffness, but it was not strong enough to make the span of 100 meters. Rather than adding expensive footings and pylons into the ground, we looked at pontoon bridges as alternative support. Combining these 2 ideas of bundled strands and floating volumes, we were able to make the span. This plan shows the layout of the bridge elements spanning in between the pontoons. And how these structural strands transitioned to the pontoons was an important feature to us, shown in this sectional detail. While the spheres needed to be of heavy construction, the strands had to be a very light yet stiff construction. So we ended up with this interesting hybrid of steel and carbon fiber composites that we developed with our structural engineer. In terms of fabrication, the filament winding was proposed to produce these very long, stiff strands, while the thicker parts of the hybrid construction would be created from conventional molds and vacuum bag techniques. This is a view from the bridge and one looking from the Hermitage Museum. And this shows the large model at 1:100 that we did for the final presentation.
The next project is a winery we designed for Bernhard Ott in Feuersbrunn in Austria. The client asked us to come up with a proposal that combines both the production facility and tasting room on this site on the edge of Feuersbrunn, which is a really small village. It's about an hour drive outside of Vienna in the Wachau, which is the Austrian equivalent to Napa Valley. Ott Wine is an international renowned vineyard, and they produce an excellent white wine. Bernhard Ott was one of the first winemakers that cultivated what's called a bioorganic wine making process, which amongst other things means there are no pesticides involved. Everything is sprayed with herbal teas and to keep the bugs off. So a big part of the concept for the project was to demonstrate the process of winemaking of a bioorganic wine through the building. There's a small taste room at the wine store at one side of the almost 100-meter long building. And through the taste room, one steps up onto the garden, which is an outdoor seating patio, but also includes a herb garden showcasing all the herbs being used for on the wines. The design again deals with edges and how to provide the transition between indoor and outdoor spaces by slowly dissolving its boundary. It does that by pinching the volume into a surface that become the canopy, which then split and finally dissolves into lines that curl up and hit the ground. It's a gradual transition from volume to surface to line. The project is a full wine production facility, which is semi-below grade, which is covered by a green roof that becomes essentially the roof garden. It's connected to the tasting room and the wine store. The wine production part of the building is designed as a gravity-fed system. That means the building section had to be designed so the wine never gets pumped but flows freely between the different stages of the winemaking process through the building section. Most of the structure is made out of curved steel pipe, which supports an inflated ETFE foil enclosure. There are different green silkscreen prints on each of the 3 layers of the ETFE foil, producing a 3-dimensional pattern.
So this is the Frank Kim residence in Pasadena. It was one of the first things we built. It was a remodel project, part of which we designed an entrance canopy for the house. The edges is what makes it interesting to us, and the fact that you can only see glimpses of the structure, because most of it's hidden and concealed, make it somewhat of a mysterious object that is kept from sight. Of course, the translucent fabric and lighting from within the structure also emphasize this idea of the uncanny object. We were closely involved with the fabrication of the steel frame, which is only supported at one point and cantilevers about 70 feet. It was built as one piece in a steel shop in Fontana, and the contractor does welding of a highly complex pipeline connections typically. This is one of the very few places that we were able to weld these extremely complex joints. This was one of the joints where I believe we had 17 pipes coming into a single point. Originally, we talked about flying the entire structure as one piece with a helicopter, but it ended up to be cheaper to cut it into 4 large chunks. These chunks were pre-painted and then brought to site and welded back together, which took only 1 day. And at night, the canopy has a changing light scheme produced by colored LEDs, which can even be seen from some LAX flight paths. We spent a lot of time on the lighting to produce a very specific effect, where the edges become blurred to produce this ambient figure. We developed a technique of different lighting intensities on each of the surfaces to produce multiple zones, rather than an evenly lit light box. Our client, who obviously was very supportive of the project, is still amused that the response from many of the neighbors and visitors is one of unease and uncanniness. The question often comes up if it can move or unfold, in other words, if it can animate into something else.
Next project is a performance center for Taipei in Taiwan, which is a competition entry from many, many years ago. But we still like to show this project because it was one of the first ones we explored the idea of the blurred edge, or the surface. In this case, is articulated through a series of creases and seams and cuts that are peeled apart to reveal part of the interiority of the object. Openings and surfaces here are part of the same design logic. The program consists of 3 performance spaces for a total of about 5,000 seats theater. It includes an opera house, a theater, and a multi-performance space. The front part of the performance center is lifted off the ground to make room for a large outdoor plaza on this otherwise very tight urban site. It creates a linkage space between the train station and night market to the north and the rest of the urban fabric to the south end of the site. The linkage space is pulled up vertically into the building, creating the central lobby and grand staircase from which all 3 theaters can be accessed. The Performing Arts Center sits on the plinth, on the thin plinth that is peeled off the ground and houses the entire retail program, which was a big part of the overall program to activate the site.
So the Firestone Project is a mixed-use office building for a developer in Downey, California. This is one of those projects where we were really hoping to get it built. It was an ideal client, very supportive, and so was the city, and they really wanted this project to happen. Unfortunately, it was designed right before the recession hit, so it ended up in an exhibition called Never Built Los Angeles instead, which was curated by Sam LaBelle at the A&D Museum. The project is located on Firestone Boulevard, an old school river road, and was designed as a gateway project for a whole series of development along Firestone, which was part of Downey's downtown development plan. It would have been one of the first all-fabric office buildings, part of which were transparent and others translucent, utilizing a unique nanogel insulated fabric to let some light through, yet able to deal with the shading and thermal issues associated with this type of space. The building is organized around a central void, which includes a staircase that connects all 3 floors, and also divides the floor plates into different zones, so it can be eventually used by different tenants. The ground floor includes a small cafe with 2 retail stores and is set back from the property line to allow for outdoor seating and landscaping. Another feature inside the void is what we call the rain catcher, which means the envelope was pulled through the interior of the building and collects rainwater for the building's gray water system. The upper levels are laid out as an open office floor plan, which is again divided into different zones on each floor to allow for different tenants to occupy the space and still maintain a level of privacy. The energy concept developed for the project included a radiant floor and ceiling heating and cooling system. In addition, chilled water was pumped through the entire steel structure of the building to provide radiant cooling along the facade. Similar to the Frank and Kim canopy, this project deals with bleeding of surfaces and blurring of edges by using both transparent and translucent architectural fabric that is attached to the bent steel pipe structure. Only part of the interior is revealed through fragments of transparencies in the envelope. At night, the opaque facade turns into a translucent canvas for projections and light.
Multiples. The final topic we want to discuss is multiples. Many of our projects deal with the aggregation of a family of self-similar objects in one way or the other. The object usually share a genetic code that has to do with its morphology or its color, and which is then being aggregated into a larger whole, while one is still being able to read individual parts. Freud, in his text about the uncanny, refers to this theme of the double, or the constant reoccurrence of similar situations throughout several consecutive generations. Michael Reese's sculpture also deals with the double, but seems more generative and variable. While parts of the initial figure are still intact, they are often edited to a few features and rejoined to form a new character. These are objects with discrete but edited features that are then aggregated into a larger whole. In our work, these processes of aggregation of self-similar objects into a larger whole, each object is edited to adjust to its neighbor. The goal here is to produce a multidirectional aggregate that offers multiple openings and access points and breaks down the barrier between architectural object and the human body. Aggregating families of self-similar primitives into a larger whole was the main design concept for us, what is called City Futura project for the city of Milan. We were one of 10 architects that were invited to propose an urban megastructure for the city expansion on the outer ring of Milan. The final project was exhibited at the 2010 Venice Biennale. While working with 3 central elements of urban design, the block, the grid, and the void, the question was how these components can be advanced into an urban megastructure. The void. We designed the void as a spherical objects, which we called supercenters, that were organized around different programmatic topics. These megacenters were positioned across the site, floating above the ground and varying in size and height. They became placeholders for enormous civic arenas, which expanded up to 250 meters in diameter. The block. We designed a 3-sided city block, which had the consequence that it could not put laid out on the ground flat. Instead, it needed to be aggregated through nesting them into larger sets. And finally, the grid, where these aggregates were then spooned around the spherical supercenters, which served as scaffolding for deploying this new kind of urban tissue that is not defined by conventional massing and zoning rules within the 2-dimensional city grid, but is based on linking together families and self-similar primitives that form a thick urban liner around public spaces. The City Futura is a city above the city. It's about 600 meters tall, 6.5 million square feet big, and provides room for about 70,000 inhabitants. This urban megastructure is superimposed over the existing footprint, leaving most of its buildings untouched and tapping into existing infrastructure and expanding it. As a side note, the Biennale model is probably one of the largest ABS prints we ever printed in our office, and it took about 1,200 hours to print this model.
Now, totally jumping scale from an urban megastructure to a living room accessory. A couple years ago, we were amongst a few LA architects asked by the Mack Center, directed by Kimberly Myers, to design a lamp. Ours was a 18-inch pendant lamp, which is 3D printed out of ABS plastic, and lit with LEDs that produce a changing range of colors. For this project, we were working with a family of tubular primitives that were joined at the hip to produce a multi-directional object. The aggregation uses a branching algorithm that starts from a single stem and works its way outwards. The lamp has two components, an outer shell with a locking device on top, and what we call the stem, which basically is a 3D printed element that's covered with LEDs. The stem can be unscrewed and allows the lamp to come apart so the LEDs can be replaced if needed. The multi-directionality of the lamp helps to direct the light from the LED source from the center outwards. The surface texture was designed with varying material thicknesses that allowed for different light densities to shine through the surface. In 2013, we met a client for Pedestrian Bridge in for Vipro, a Indian IT and software company. They have a large campus outside of Bangalore, which is in central India, and approached us to work on a couple of smaller projects, including this pedestrian bridge. Currently, their campus is separated into two parts by a public street and joined through a pedestrian bridge that they wanted to redesign. Our initial approach was that the bridge needed to do more than just connect between two parts of the campus. The client wanted the bridge also to be an iconic gateway for the campus. The bridge design is an aggregation of tubular elements that form outriggers and can be used as informal areas to meet and hang out. The bridge has multiple openings that offer different vantage points to the campus, the sky, and the ground. The structure and skin are collapsed into a single element, so there is no need for additional structural support. The tubular geometry is strong enough to make the span, and the additional creases and flutes help strengthen it even more. The whole bridge is made out of half-inch thick steel plate, which is polished on the exterior. India has a huge shipbuilding industry, and we started to talk to some of these folks. They were quite accustomed to working with compound curved metal and the welding of large continuous structures. So the bridge was conceived to be built as one piece in one of the local shipyards, and then cut apart, and then shipped to the site and welded back together.
This was a competition entry for the new shipping terminal in Keelung, Taiwan. The project deals again with an idea of aggregation of multiples, but also with apertures and edges. There are essentially two components to the project, which needed to be constructed in two phases. The cruise ship terminal itself, which is a horizontal aggregation of flute-shaped objects into a thick slab, with multiple openings towards the harbor and including the different boarding gates. The office tower, which were part of the second phase, are bundled together into one mega tower. Urbanistically, the goal of the project was to sponsor a new development along the waterfront and to become a new iconic entry for the harbor. An urban waterfront promenade would be integrated into the terminal building and connected with the adjacent development. So our proposal was to raise essentially the promenade off the ground and allow for the cargo and loading to happen on the dock level, while creating a new exterior plaza at the front of the terminal and a new plinth or datum line for the project. The terminal passenger level is in pink with the subdivision of each gate articulated through the massing and the corresponding openings. On the interior, the individual flutes are intersected to form a single open space. The project deploys apertures in two different ways. Mega aperture that frame the view to the harbor and become a spatial divider between the different gates, while the smaller apertures are inserted into the roof as a way to give scale and color to the vast expansion of the interior space. On the exterior, the mega apertures are operated as transitional objects between inside and outside, adding specific features like texture and color to the overall massing, while the surface of the flutes are heavily articulated with apertures that disrupt the continuity of the surface and produce an architecture that appears to be incongruous.
So this project was, again, for a developer, which included a stadium, a couple of hotels, and an office tower in Rio de Janeiro, Brazil. The first design phase was focused on developing a master plan that had a 65,000-seat soccer stadium. A big part of financing for the stadium had to do with designing a venue that could be used year-round and not just for soccer games at the local club. One of the main premises was that the stadium was supposed to become the final destination for Rio's Carnival. Although the stadium itself was designed specifically for soccer, it also needed to be compatible with a whole series of other sports, concerts, and other events. The program also included a large retail, restaurant, and entertainment component that needed to be integrated somehow into the development. So rather than distributing this program throughout the site, the idea was to develop a double-layer stadium, which means the inner layer deals with the soccer stadium and all the required amenities, while the outer layer of the stadium includes the restaurants, bars, and retail, and other types of entertainment. So the strategy allowed us to argue for a venue that is operable 365 days a year, which makes sense from an operational point of view, while at the same time arguing for this hyper-articulated geometry of the enclosure to make sure it doesn't get value engineered away. The section shows the stadium with a second layer that holds all the retail and entertainment components of the program. So even when there's no game or concerts, the stadium can be used. The layout configuration of the stadium itself is governed by many rules and regulations that deal with everything from sight lines to shadow paths of the field to strict FIFA regulations. We tried to get the people as close as possible to the field, while at the same time remaining some sort of flexibility in regards to other sports. Like many stadiums, this one included a retractable roof. We studied different design options and looked at deploying a mega aperture that could open and close through a spiral motion. The whole development sits on a large plinth and designed to create a new elevated park for the region with parking on the ground level. The design, again, explores aggregation of a volumetric primitive to create a thick liner.
Okay. Funny movie. So we want to finish by showing a few projects that we're currently working on and that you haven't seen yet. So these are designs that are not yet finished and are really a work in progress, but sometimes it's good to show these things at this stage anyway. And so the projects are at three very different scales. It's a chair, a house, and a transit center. And they're all dealing with topics of apertures, edges, and multiples. The first project is a lounge chair that we were commissioned to do. And these are basically different design iterations where we explored a series of profiles and articulations. From the get-go, we wanted to do a chair that is volumetric, which means it has an interior void and openings into it, and that would partially reveal the interior. Although you can't really experience the inside of the chair, you can see inside it and know it's there, and you ask yourself, why is it there? And it's just being uncanny in that way. So we started out with a single tubular shape with a kink, then it was split into two tubes that were joined by the hip. The next generation or iteration added creasing and further articulation to the armrests, and we like the idea that the chair is neither a bent surface nor an enclosed volume. And then we started working on the padding, which likely would be made out of charcoal color polyurethane foam. So we used the same polyurethane liner to articulate also the seams of the chair, forming some sort of a ligament that connects the white fiberglass shell. And spent a lot of time studying these different sections and profile cuts of different lounge chairs by many designers just in terms of stability and comfort and size. So that's the current profile of the chair. And we wanted the chair to be mostly comfortable. It's not an art piece, it's a chair you want to kick back in and watch TV or have a glass of wine. There's some 3D model studies looking at the overall design. It's not, as I said, it's not quite there yet. So when you design a chair, the elevations are a good tool to analyze the chair and its shape. We wanted there to be a loose reference to a lazy boy chair, so that there is the familiar aspect again, while at the same time there's some uncanny features that don't belong, like the openings that are cut into the front and back, and give a visual access to the inside of the chair, which is painted lime green. In terms of materiality, we wanted the chair to be ultra light with thin edges along the openings. So depending on from where you look at the chair, it will look either very chunky or heavy from the side and back, and ultra thin from the front and top, where you can read the material thinness. The majority of the shell is made out of white fiberglass, and as mentioned, has embedded a charcoal polyurethane foam liner. We just started talking to fabricators to produce a first prototype, which is supposed to be done in February. And then the chair will go into a couple of different furniture shows, design shows, starting next year with the furniture show in Milan and Art Miami.
So this is a residence we're working on, currently in schematic design. It's located in a steep hillside in the Hollywood Hills with amazing 180-degree panoramic views, looking over Hollywood and towards Capitol Record building. A lot of the initial work had to do with where to best locate the house and how to address the hillside. There were a lot of studies on how to utilize the 6 parcels of property through terracing and landscaping the site. And we had to strategically design a long driveway that would be needed to get up as high as possible. There were many configurations studied that dealt with the views and what you can see from each room. We use these studies to develop the large-scale apertures that aggregate into this multi-directional object hovering above a main deck. Where the building is settled so far is with a large cantilevered plinth condition for the lower part of the building, which is open and has a flexible plan. And that is then covered by a floating object for the second floor, shaped to take advantage of the unusual zoning envelope and providing shading for the lower floor. The second floor amounts to what obviously can be seen as a multi-directional object oriented towards the surrounding vistas. There's a cantilevering pool that extends over the driveway and has a large window along which you enter up onto the deck. The second floor of the house has a family room, guest room, and 2 bedrooms with a master suite. The master bathroom has direct access to a private garden on the second floor. Here are some pictures of the 1/8-inch scale design model that we've built. As mentioned, the project is still in development, so we also did an alternative scheme for this stage. With this, we kept the lower floors set up as it is, but the upper level is dramatically different. The project is concluding many of the research topics we elaborated on before that have to do with apertures as an object being inserted, in this case, into a thick slab forming the second level. This is hovering above mostly a glass enclosed ground floor that can be opened up through large sliding windows and doors to produce continuity between indoor and outdoor living, very much in the spirit of the case study houses. The house is made entirely out of FRP and is designed similarly to our gallery installation as a single surface shell that not only provides the enclosure for the project, but also integrates the structure, insulation, and solar panels into a single surface. We're currently working together with Bill Chrysler and Associates and our structural engineer on a preliminary constructability study for this project.
The last project we want to show is this transit center for Northern California, which we won the RFP about a year ago. And that's currently still in schematic. That's working for the government. The project is a transit center for about 20 buses and consists essentially out of a large roof and a small terminal building. So there's an existing bus station at this location which is supposed to be demolished. The transit terminal will become a major hub for the region and connect the city with Santa Cruz and Monterey. The project recently changed. That's part of it why it took so long and doubled in size. So the version we're showing here is still the smaller version of the roof, which need to be expanded over another 2 bays. So we consolidated all of the programmatic elements into a single terminal building on one end of the site and kept the majority of the tarmac completely open and covered by a large roof. Obviously, we are not doing just the typical transit center roof. Of course, it does everything this type of roof needs to do in terms of covering and shading passengers while they wait, but it also asks the question what else it can be. It was important that the roof is an object and not just a surface. The thickness of the roof allows for the structure to span over a long distance to open up the plaza as much as possible. But more importantly, it created an elevation that has strong presence and opened up an opportunity for design for us. The roof integrates solar panels and apertures. Those apertures are uncanny features that point to something else or have a purpose that is not immediately apparent. So in conclusion, for us, the question of the familiar and the uncanny in architecture remains one that we will continue to explore. It is not tied to a specific architectural vocabulary or formal preference, but rather an attitude towards creating architectural environments which cannot be immediately understood by simply understanding its parts and their relationships. It's an architecture that engages both forms of abstraction as well as forms of resemblance, producing a strange fusion between the two. We will end with a short video of the production of the SCI-Arc Gallery piece. And I'm going to just explain a little bit the video. Obviously, everybody has seen the installation, but maybe not everybody is that closely familiar with the production of it. So we basically milled 233 individually formed panels out of polyurethane foam for about 2.5 months with students producing these like fairly large molds that were all compound curved, milled, glued together into larger pieces. And it was really a huge effort to get these pieces all assembled. These are the final molds. They needed some minor sanding. We milled about 2 shipping containers full of polyurethane foam. So this ton of foam went into this thing. Then these panels were shipped into to Warner Brothers, which has an industrial-sized vacuum forming machine. These folks there were basically taking each mold, putting what's called a gray skin over it. That's a separating layer to be able to take off the final finished material. So they trim it, and then they pull over a 1/8-inch thick PETG plastic, which is a very cheap water bottle plastic like this. Fairly weak, but the geometry obviously helped to stiffen the whole thing. So brought everything back to SCI-Arc. Students cut all the panels off the molds, and those molds were then painted from behind. We needed to construct the wood scaffolding just to be able to register the pieces. It's not actually holding up anything. I mean, unless the pieces, until they're completely assembled, they are fairly weak. So we took the wood scaffolding out as soon as that was put together. And what you hear in the background is some of the sound features that we installed into the opening. So there were heat sensors in each opening that would pick up your body heat and then transform it into a sound composition, a sound feature. This is the interior space, which we actually were, this is one big open shell, multiple vantage points out, and obviously everybody remembers that. That's from the opening of the final piece. So I also would really, at this point, I want to really thank everybody that, especially Eric, John, Hernan, Ming, to support us with this. This was, I understand, pretty long and painful process, but we're pretty happy with the piece, so thank you for giving us the chance. And especially I want to thank the students that really worked put an incredible amount of effort into putting this thing together. We would have not been able to do this without you guys, so thank you very much.